Question from February March 23. With respect to the origin O, the points A, B, C, and D have position vectors given by, so there are four position vectors given for the points A, B, C, and D. Find the obtuse angle between the vectors OA and OB. So formula for the angle between two vector is here. So scalar product we know is A dot B equals to magnitude of A, magnitude of B into cos of theta. This is the definition of the scalar product, and from here you can make cos of theta the subject. So cos of theta is A dot B over A magnitude, B magnitude. So we have a scalar product in the numerator, and the denominator is the product of two magnitudes. Scalar product of two vectors, if the vectors are given, if the column vectors are given a, b, so the scalar product is x1, x2 plus y1, y2, multiply the corresponding entries, x1, x2 plus y1, y2 plus z1, z2. So multiply them, multiply and add. And the magnitude, if the vector is given PQR, this is vector A, the magnitude is p square plus q square plus r square. So vector can be given in the column vector form or in IDK notation. So these are the three concepts which we need for this for solving this question. So here, first of all, and the two vectors are OA and OB. The formula for the angle between these two vectors, I'm writing here, cos of theta is the scalar product of these two vectors in the numerator, and the denominator, there's the magnitude of A multiplied by magnitude of B. So vectors are given. You can find the scalar product 3 minus 1 2 dot. This is also called the dot product. Multiply the corresponding entries. Minus 1 is multiplied by 2, 2 is multiplied by minus 3, and we have 3 minus 2 minus 6, which simplifies to minus 5. This is OA dot OB. You can find the magnitude of these vectors. So OA is 3 square plus minus 1 square, 2 square equals to 9 plus 1 plus 4 is 14. And OB magnitude, the vector OB is there. So the magnitude of vector OB is 1 square plus 2 square plus minus 3 square, which is 1, 4 plus 9, again it is root 14. So after finding the scalar product and the magnitude, so just plug in the formula. So we have OA dot OB over OA magnitude. This is the formula for the angle between O and OB. So cos of theta minus 5 over root 14, root 14. Cos of theta is minus 5 over 14, and theta is cos inverse of minus 5 over 14. Use calculator. This answer is coming as obtuse because of negative. So 110.9248, or correct to one decimal place because we write answer, non-exact answers for the angles correct to one decimal place. This is answer correct to one decimal place. The second part, the line L passes through the points A and B. Find the vector equation of the line L. So there is a line L passing through point A and B. The position vector of these 2 points are given. So vector equation of line L. The formula for the vector equation of line is here. R equals to A plus T into B is the formula for the vector equation of the line. So if there is a line passing through a point A, if there is a line passing through point A, and this is a line L, and it is parallel to a vector B, so R equals to A plus TB is the vector equation of line. Here, R is the position vector of the variable point on the line. So the important thing here, A is the position vector of any point on the line. It is the position vector of any point. T is called the parameter, and B is the direction vector. This is basically any vector. Direction vector can be any vector which is parallel to the line. This can be in any direction, but parallel. As far as we know, a vector which is parallel to the line, that can be used as B. So any multiple of vector, any multiple can be used if the vector, if we know the vector which is parallel to the line, so any multiple of that can be used as the direction vector. So here I'm writing R is equals to any point position vector T into direction vector. So just keep in mind this formula, R equals to A plus TB. So for solving the second part, we have R equals to A plus TB. The formula R equals to A plus TB. We have the understanding that R and T will remain there, and A and B are the two important things which we need. A is the point position vector, B is the direction vector. So we need to find a vector which is parallel to the line L. It's not clearly mentioned there, but the 2 points are there. So when you find a vector joining using these 2 points, we can draw a vector AB, and this vector AB, which you can find by using the position vectors OA minus OB minus OA. So this vector is obviously on the line L, and this can be used as the direction vector for the line L. So we have OB and OA, just used OB and OA, 1, 2, minus 3, and 3 minus 1 and 2 is equal to simply using plus minus 1 minus 3 is minus 2 here, 2 minus 1 is 3 here, and minus 3 minus 2 is minus 5. So minus 2, 3 minus 5, this is a vector, this is vector AB, and this can be used as B for the equation of line. So this can be used as the direction vector for the line. So R is equals to A plus TB. So we have formula R is equals to A plus T into B. R is R, and A is any point, the position vector of any point. It can be the position vector of A, it can be the position vector of B. Let us use the position vector of A, 3, minus 1 and 2 here. T into B, B is the direction vector, which is minus 2, 3, and minus 5. So we have the answer to this part. So A is the point position vector, B is the direction vector, and the definition of the direction vector is that it is parallel to the line, and as 2 points were there, so you can find AB vector, and this can be treated as the direction vector for the line L. So we have the answer to this part. For the third C part, find the position vector of the point of intersection. So point of intersection of line L and the line passing through C and D. So as the point of intersection of two lines is required, line L is already there in the previous part. This is line L, this is line L, and this is line L as mentioned here. This is line L. But for the second, we need another line, and that is the line CD, the line passing through the point C and D. The same concept we can apply here. There is a point C, there is a point D, and the formula we know is R equals to A plus TB. So one important thing which you must keep in mind that yes, I'm writing for the reference R equals to R is equals to A plus. So normally we write A plus TB is the standard formula, but as this is the second equation of the same question, the second equation of line in the same question, so don't use the same parameter, use R equals to A plus S into B. So A is same, the position vector of the of any point, and B is the direction vector, but here the parameter is different. It must be different for the same question. So C and D. So we have the 2 points there. You can find the vector CD with the help of these two, and this would be the direction vector for this line CD. So CD, I'm writing here. CD is OD minus OC. OC and CD are there. OC and CD are there. So OD minus OC, I'm finding here 5 minus 6, 11. So 5 minus 6, 11, and the other is uh, the second, which is 1 minus 2, 5. You can always simplify. So 5 minus 1 is 4. So we have 4 here. Minus 6 minus 2 is minus 4. 11 minus, so we have CD vector. So this can be used as B. But here I will give the idea that, as I said before, that any multiple can be used. So as we have 4 minus 4 and 6, so why not you take 2 common and get this in simplest form. So if you take common 2, it is 2, it is minus 2, and it is 3. So instead of using 4 minus 6 and 4 minus 4 and 6 as the direction vector, so for this case I can use the multiple which is in the simplest form, 2 minus 2 and 3. So any vector you can use for this answer. So I'm using this simplified form of this vector, 2 minus 2 and 3. So you can always simplify the direction vector. Keep in mind that we can simplify the direction vector for writing equation of line. So it was R is equals to A plus S into B. This is just for the reference. R will remain R there. A is the position vector of any point. It can be C, it can be D. It can be C, it can be D. So I'm using 1 minus 2 and 5. I'm using the position vector of C uh, plus S into B, the direction vector, which is 2 minus 2 and 3. This is the second equation. So this is the equation of CD. The question was to find the point of intersection of line L and this line CD. So two lines. So if there are two lines, intersection of two lines, if they're a pair of lines, if they're a pair of line, the two lines in three-dimensional space may be said that they are parallel, they are not parallel, and intersect. And in 3D, it is possible that the lines are not parallel and they do not intersect. Such lines are called C. So how can we know that whether the lines are intersecting or not if they are not parallel? So there is a procedure which you can apply here for this question. From this question, we can understand this concept as well. So there are two lines, and keep in mind this procedure. Uh, the lines are L and CD. So the point of intersection of these two lines is required. So as these are the two lines, write these two lines here. So write down line L is equals, line L was 3 minus 1 and 2 plus t into it was minus 2, 3 and minus 5, minus 2, 3 and minus 5, and CD line is 1 minus 2, 5 with a different parameter, 2 minus 2 and 3. So these are the two lines. One line is line L, the other line is line. So I'm looking for the point of intersection if they are intersecting. So follow this procedure. So write the equations in the parametric form. So writing both equations in parametric form. So what is the parametric form? Simple, x and y and z. This is the format for the parametric form. From here, you can write the parametric form simple 3 minus 2d. 3 minus 2d. Then minus 1 plus 3t. Then 2 minus 5t. So here you can label this set as 1. And the second, again you can write the parametric for the line CD. 1 plus 2 into S minus 2 into S, and the last is 5 plus 3 into S, and this set I can label as 2. So as I'm looking for the point of intersection, so this is the procedure for the point of intersection. So let me put the point of intersection, and I'm following this procedure. So write both equations in the parametric form. So as I'm looking for the point of intersection means the x coordinate should be equal to the x coordinate if they intersect. Then minus 1 plus, simply equate x equals to x, y equals to y, and z equals to z. So what we do after writing these equations 1, 2, and 3, so we'll solve any two of them and we'll try to find whether it is possible for this case to find S and T values which are true for all these three equations. And for this you can choose any two of the equations. So I can choose 1 and 2, and from 1 and 2 I can find the value of T and S by solving them simultaneously. And if these two equations which we are obtaining from 1 and 2, which we are obtaining by x equals to x and y equals to y, and if these two equations, these two values of s and t will satisfy the remaining equation, then that would be a confirmation that the lines are intersecting. Okay, so let us solve 1 and 2. Solving 1 and 2 simultaneously. And 3 minus 2t is equal to 1 plus 2s. I can simplify it like this. Uh, uh, 2 is equals to 2s plus 2t, 2s plus 2t, and from here, uh, 1 is equals to s plus t. You can make t subject, or so t is equals to 1, t is equals to 1 minus s. So from equation number 1, I'm solving 1 and 2. From equation number 1, t in terms of s. So you put this value, number 2. So number 2 is minus 1 plus 3 into 1 minus s is equals to minus 2 minus 2s. Simplify. Minus 1 plus 3 minus 3s is equals to minus 2 minus 2s. 2 minus 3s is equals to minus 2 minus 2s. So it is 4 is equals to s. So s is equals to 4. If x is equals to 4, so use this value in number 1, put in 1 or put here. So therefore, the value of t, 1 minus s, t is equals to 1 minus 4. The value of t is equals to minus 3. So we have s and the value of t. So after finding these two answers, these are the values of which we obtained from 1 and 2. And we need to verify this in the remaining equation. So here I'm writing verification. The heading, you can put the heading verification. Verifying in equation 3 because the remaining equation was 3. So let us check whether these two values are satisfying the third equation or not. Third equation is uh, minus 2 minus 5t is equals to 5 plus 3 into s minus 2 minus 5 into minus 3. I'm just verifying it. 5 plus 3 into 4. So answer is minus, so this was 2. This was, mm, let me verify. Yes, 2 minus 5. 2 plus 15 is equals to 5 plus 12. 17 is equals to 17. So verified. So verified. Hence, the lines intersect. Hence, the lines L and CD intersect. Hence, the lines intersect. So, if the lines intersect, then what is the point of intersection? What is the position vector of the point of intersection? So, if the lines are intersecting, obviously intersect. For the point of intersection, either you use the value of S or T. So, what happened here? Minus plus equals to minus. So either you use the value of S in number 2 or the value of T in number 1, the point of intersection will be there. So use the value of put S is equals to 4 in number 2. X would be 1 plus 2S 1 plus 2 into 4, which is 9. Y is equals to minus 2 minus 2S. So minus 2 into 4. So the answer is minus 10 and Z is equal to 5 plus 3S. 5 plus 3 into 4 equals to 17. So the point is 9, 10, and this is the point of intersection. This is the point of intersection. So for the point of intersection, the position vector is of point of intersection is 9 minus 10 and 70. Okay, you can verify this answer instead of using S if you use the value of T here in this set of equations. So you will find the same values of X. 3 minus, so let us verify. 3 minus 2 into, so the answer is same as 9. Then minus 1 plus 3t, minus 1 plus 3t is minus 10. 2 minus 5s is 17, so the same. So you can verify your answer. So the answer which we are obtaining for the point of intersection by using the value of s in the second set, the same coordinates you will be getting if you put the value of t in the second set, because the lines are intersecting. So and if for instance by after finding the value of s and t, the remaining equation is not verified, so we write the lines are not intersecting, and if the lines are not intersecting, there is no point of intersection.